Counting Techniques and Probability Part 3. Permutations and Combinations. Let's start this video with an example. In a 10-horse race, how many ways can the horses finish first, second, and third? Note what we're doing here. We are going to choose 3 things out of 10 where the order matters. That is, it matters which horse comes in first, second, and third. And we want to see how many different ways we can order this. Well, we've talked about the multiplication rule of counting before. So in a 10-horse race, 10 horses could come in first, which leaves 9 horses for second, and then only 8 horses for third. So 10 times 9 times 8. In the last video, we discussed factorials. Notice that 10 times 9 times 8 equals 10 factorial, which is how many different things there are, in this case 10 horses, not divided by 3 factorial, but 10 minus 3 factorial, which is 10 factorial over 7 factorial, which exactly equals 10 times 9 times 8. So we have this idea of something called a permutation. A permutation counts the number of ways we can choose our things out of n choices where the order matters. The general notation is NPR, as we see on the left. An example that we're going to do in just a bit is 4P2, where I have 4 things I would choose 2 out of them. But the formula for a permutation, and once again, the permutation is counting how many different ways we can do something. In this case, choose R things out of n choices. NPR equals n factorial over n minus r factorial. So we don't necessarily need to use a formula for this, or even factorials, because we already have a way of doing this, as we talked about to start this example, kind of the old school multiplication rule of counting. But there may be times when using this formula is simpler for us. Side note before I go any further, very often permutations and the next idea we're going to talk about, combinations, can be found simply by using a calculator. There's usually a built-in program that finds permutations and combinations, but we're going to do a little bit of work by hand. So back to my example of 4P2, this is 4 factorial over 4 minus 2 factorial. And we're going to simplify this. So 4 factorial over 4 minus 2 is also 2. And so we can write it out one more time, but we'll probably skip right to some of the answers later on without all this work. But 4 factorial is 1 times 2 times 3 times 4. 2 factorial is 1 times 2. So 4P2 is 12. Okay, what does that really mean? Well, let's come back to that after we talk about the idea of a combination. Now, a combination counts the number of ways we can choose R things out of n total choices where the order does not matter. The notation for a combination is NCR. Now, for example, we could have 4C2 like this. Now remember, these are counting techniques that we're going to use later on when we do probability. Now let's go back and dig into both permutations and combinations a little bit more and see how they relate. Let me put the formula for permutations back up here, because this formula I think is pretty easy to see where it comes from. Now let's look at combinations. Let's do 4C2 over here. What does that really mean? Well, it means we want to choose 2 things out of 4 then count how many things we have. That's what a combination is, where the order does not matter. So let's actually do something where we have 4 things. Let's have the set A, B, C, and D. And we want to choose 2 out of the 4. Well, we could have AB, we could have AC, we could have AD, we could have BC or BD, or we could have CD. These are all the combinations that we could possibly have. Now, 4C2 is not this set of things. 4C2 is how many things we have in this new set of 2. And we see that 4C2 is 6. When we choose 2 things out of 4, we get 6 different things. Well, how about a permutation? What if we want to do the same thing, but the order does matter? Well, let's start listing them over here. We could have AB, but BA is different than AB. So that's what we mean by order matters or does not matter. In the first column, AB and BA are the same thing. The order doesn't matter, so they're the same thing, so we don't list them separately. But in a permutation, A, B, and BA are different things because the order does matter. And then we could list all of the different permutations using my combinations to help write them out. So in this right column, we have all the permutations. Notice that there are 12 permutations when we choose 2 things out of 4. More specifically, or maybe extra, because what we want to do is relate the number of permutations to combinations, because we already have a formula for permutations. We see that 4P2 is twice as big as 4C2. All right? Because anytime we have 2 things in our combination, there were 2 different ways we could order them. And so we see that 4C2 is 4P2 divided by 2. And I'm going to leave a little space, even though you might not see the space. Because again, our goal here is to try to find a formula for combinations based on permutations. Well, let's do 4 combination 3. So once again, we have a set of 4 things, A, B, C, and D. And we're going to choose 3 out of them, where the order does not matter. So I could have A, B, C. I could have A, B, D. Or A, C, D. Or B, C, D. And these are the only 4 combinations I can make, choosing 3 things out of 4. How about our permutations? Once again, we could start with A, B, C. But the order does matter, meaning ABC and ACB are different. Still using only A, B, and C, BAC and BCA would be different. And then CAB and CBA would also be different things. And I could do the same thing with ABD. I'll write these out. Getting all the different combinations, the permutations, because the order does matter, using A, B, and D only. And I don't think we need to write any more, because we notice, I hope, that there are 6 permutations for every combination when we choose 3 things. So we could say that for choose 3, that is for combination 3, is for permutation 3 divided by 6. Now, do you see a pattern here? Maybe. If not, let me add just a little bit extra here. What if I realize that 2 is also 2 factorial? So when I choose 2 things, I'd have a 2 factorial. And 6 is 3 factorial. Now, I'm not proving anything, but I'm trying to convince you of the following. Hopefully I have. That just in general, if I want to find out how many combinations I have, I can find out how many permutations I have, and then divide by an extra r factorial, which is how many things I'm choosing out of the total. So the formula that you'll often see given for combinations is the following. Instead of in terms of the permutation, we say it's n factorial over n minus r factorial. There's your permutation. And then divided by an extra r factorial. So let's just do a couple simple examples. Let's do 5 permutation 3. So if you have a calculator with a program, feel free to just plug it in and get your answer, but I will do this one by hand. So 5 permutation 3 is 5 factorial over 5 minus 3 factorial. Then we can start simplifying. We get 5 factorial over 5 minus 3 is 2. And then 5 factorial divided by 2 factorial is 3 times 4 times 5, or 60. How about 5 combination 3? Well, 5C3 is 5 factorial over 5 minus 3 factorial divided by another 3 factorial, which is 5 factorial over 2 factorial times 3 factorial. Now, I already have this part above, right? So that's 60 divided by 3 factorial, or 60 divided by 6, which gives us 10.